All right, here we go. Number one. So you're going to have to do two things. Graph the function and the parent function. So I'm going to get out my graph paper, and I'm going to start working on, I know the parent function. I know exactly what that looks like because it's an x squared. So I'm going to go straight to graphing it. And I know the parent function looks like this. The parent function is y equals x squared. We know exactly what that looks like. The parent function 0, 0, 1, 1, 2, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the parent function looks like this. It is a parabola. We need both. Everybody should be able to get the parent function correct. It's a parabola. It's a parent function. Now, in vertex form, this parabola has a vertex at positive 4, negative 9. So we're just going to move this parabola to 4, negative 9. And I'm going to redraw my parent function here. 1, 1, 2, 4, 5, 6, 7, 8, 9. That's it for number one. Have my parent function, they both. And I moved it to 4, negative 9. All right, let's take a look at number 2. Number 2 says that g of x can be reflected over the x-axis and a vertical stretch of 1/2, followed by a translation 5 up and 1 unit to the right of fx. So this is an absolute value. So we're going to take g of x and reduce some things. So first of all, to reflect it over the x-axis, it makes it negative. Okay, that's going to make it negative. So I'm going to go at negative absolute value of x. Okay, so negative. And then I'm going to have a vertical stretch. So I'm going to make it half as tall. So I'm going to make a 1/2 here, a negative 1/2. So negative 1/2 here. Followed by a translation of 5 up. So that's 5 up is plus 5. But anything on the inside is always the opposite. 1 to the right. If it's on the inside, it's going to be opposite. So instead of going plus 1, we actually go minus 1 because it's got to be the opposite. And that's going to be my new function. Okay, let's take a look again. Over the x-axis, I made it negative. So I'll rewrite this so it's easier to see. I've got a negative vertical shrink of 1/2 or stretch. There's my 1/2 absolute value because that's my parent function. I'm going to go to the right 1, so it's the opposite of the inside, minus 1. And then I'm going to go up 5. Okay, that's number 2. All right, number 3, how am I doing? Oh, I'm not done. Number 3, I'm not done. Domain and range. Now I need domain and range. So it'd be helpful if I kind of knew what this looked like. I do know it's upside down. That helps a lot. So it's just a real rough sketch. Because it's upside down, that helps me a lot. It's going to be at 1. The graph itself is going to be at 1, 1, 5, and it's upside down. So the graph looks like this. Doesn't have to be perfect. I just have to have a general idea of what it looks like, okay? So domain, it's forever y. That's easy. Domain is forever, ever going. So the domain is going to be x equals all real numbers. Because it's forever y, it's all numbers, okay? The range, though, is reach for your range. Starts at a height of 5 and goes down. So the range, we're going to say, is y is less than or equal to 5. Starts at 5 and goes down. We've learned this before. This shouldn't be too bad. All right, now number 3. So number 3, I'll do on this paper because I have room. Write an equation of a line and interpret the slope. Okay, so it is a straight line. So we're going to use y equals mx plus b because it is a straight line. I'm not sure what the slope is, but I can find the slope. So the slope is going to be rise over run is my slope. It doesn't rise at all. In fact, it goes down. It goes down 200. From 600 to 200, it goes down 400. So it goes from 600 to 200. So it goes down 400. But then it goes over, from 1 to 5, it goes over 4. So it goes down 400 and over 4, which gives me an answer of negative 100 for my slope. That's m. So the b, I'm not quite sure where the b is. It looks like 750. But I can then find out what it is. So I'm going to find b by picking either point. This is probably the easiest point. So every point's got an x and a y value. I'll put the 600 in for y. I know what my m is. And I'll put the 1 in for my x, and then I can solve for b. So I can solve for the y-intercept. All right, so it looks like it's going to be 700. So 600 equals negative 100 plus b. And then solving is pretty easy. I'm going to go plus 100, plus 100. 700 equals b. And so then I'm just going to rewrite it finally and answer y equals negative 100x plus 700. Now, interpret the slope. I want words. Write this down. I want words. What words am I going to use? Well, it has to do with sales per year. The words, sales per year. So it's going to be sales per year. And that's what I want is words. What does slope mean? Sales per year. You're losing sales per year. It doesn't look like home phone sales. Yeah, because everybody has cell phones now. Nobody's buying a home phone anymore. Okay, number 4. We keep doing this again and again, but I don't mind doing it again because hopefully we're getting good at it. So what I'm going to do is, it says vertex. So that is a big clue to me. It says vertex, I have an equation that is y equals a x minus h squared plus k. That's my vertex. And so I'm going to put my negative 6, negative 12 in. Oh, this is the exact same one we did in our warm-up, which is nice because we have done it before. So here's my h and my k. And I'll go y equals a times x minus a minus 6. And Alonzo, I agree. I'm going to make that a plus 6, right? And then plus a negative 12, which I'll just make that a minus 12. So let's make that plus plus right off the bat. I agree. Now I need more information. If I'm going to find the value of a, I need more information, which I do. I've got a point. I've got a point x, y. So I'll put my negative 24 here for y. I'll put my 0 in here for x. So I'm going to have and we can solve for a. So to solve for a, I'm just going to go ahead and simplify this. I've got a negative 24 equals a times 36, because 6 squared minus 12. I'm going to go plus 12 plus 12. I'm going to go negative 12 equals 36a. Still solving for a, so I'm going to divide by 36. And that'll reduce to a negative 1/3 as a fraction. Now, I want the equation, right? That's the whole idea, is to get the equation. So I'm going to take my negative 1/3, I'm going to put it right there. So I have an equation. So my answer finally is a y equals negative 1/3 x plus 6 squared minus 12. That's the equation of the parabola with this vertex, and it will pass through that point. Okay, we can do this. We've done this before. I know you guys can do this. Okay, there's my answer. All right, number 5. Now, number 5. You have your calculators, right? I'm going to teach you another way to do it. The calculators can do these. Before we had to do elimination, there's another way to do it. There's an easier way of using the calculator. So I want you to take good notes, okay? First of all, the calculator will take numbers, but it takes numbers in what we call a matrix. So what I'm going to do is make a matrix with just the numbers. 3, 5, 4. 5, 2, 3, 6, 3, 4. Okay? Again, the calculator can do this. The calculator needs to have numbers. So I'm going to make these boxes to put in my calculator. So my other matrix is going to be a 13, a -9, and a -8. Okay? I'm going to put these numbers into my calculator and let my calculator do the work. Okay? So here's the steps. Step 1. Find the matrix button, which is in blue. It's in blue, so we're going to go second matrix, okay? So here's our steps. You can find the matrix button. And then I want to go to edit, because when you edit, you create or change, just like the other stuff. Edit. Okay, we're going to push edit, so I moved it over to edit. Okay, follow along with me. Thumbs up, you guys okay? All right. And I want to make matrix A, and I'm going to let this be matrix A, and it has 3 rows and 3 columns, so its size is a 3 by 3. So when I make matrix A, I want to make sure it is a 3 by 3. So when I call it a 3 by 3, it makes the box big enough for those numbers. If I call it anything else, for instance, if I go, okay, what if I call it a 2 by 3? It makes the wrong box. We need a 3 by 3 to make the right size. So it'll work. 3 by 3. 3, enter 3. Okay. Now I'm just going to type over these numbers. I've got numbers in there. I'm editing. So I've got 144, 12, 1. I'm just going to type over. So I'm going to go 3. So I'm going to type in my 3, my 5, my 4, my 5, my 2, and my 3. Okay. And then my 6, my 3, and my 4. Okay, so this is much easier than the way we did with row operations. Much easier. So in my calculator now, A's in it. Okay, as long as I don't clear anything, A's in it. Okay, thumbs up. Already have A in there. Any questions? Anybody need any help? Okay, now I'm going to hit stat. I'm going to hit matrix again because I need to make matrix the other matrix. So I'm going to go ahead. So edit and then enter data. I want to go 3 by 3. I'm going to enter data. Enter data, which I just did. And now I'm going to hit matrix again. So hit matrix again, second matrix, because I need to make the other one. So I've got 2 matrices, and this is a 3 by 1 because there's 3 rows, 1 column. So I go to edit again. Go to edit again. But this time I want to edit B. Let's call this one B. Matrix B, okay? So this time I'm going to edit B, so I moved it over to edit. Right there, moved it over to edit, and I moved it down to B, okay? Moved it all the way over to edit. Okay? So how's everybody doing? Okay, am I all right? So when I push enter, 3 by 1, it is. I need to make sure it's 3 by 1 because that'll fit these numbers. So it's 3 by 1. And I'm just going to put these numbers in. 13, -9, -8. Okay, this is so much easier. I didn't show you this before because I wanted to actually do the row operations. But this time let's let the calculator do it, okay? Now, I'm ready to go. So I'm going to go ahead and get out of here. So I'm just going to put quit. Quit is right there in blue, second quit, okay? Don't push clear. Okay, quit. So here's what we need to do. And it's actually real easy. The calculator will get the answer. I need to do this little operation. You need to do this. A -1 times B. Okay, let me go ahead. I'm going to highlight this. This is what we need to do. This is the math operation, okay? So how do I do this? We're going to go back to matrix. Yep, clear. And there's A and B, not added, but A and B, because we already made them. That A, in my calculator, is that A, okay? We made it, right? So I push enter, and A pops up. That's what I want. Now I need this little -1 button, which is right there. See the X -1? I need that little -1 button, so I'm going to push that. And I need a little time symbol. And then I need to find matrix B, but that's in matrix, right? I need to find B. So I go back to matrix, okay? So I hit matrix again. And there's B, right? So there's B. I've got B. If I hit enter, and B is going to pop up, okay? So enter. Now, this is the formula of my calculator for solving this. So I hit push enter, and there it is. That's the answer to X, Y, and Z. So my answer, my calculator, turns out to be the point -3, 6, -2, okay? All right? Want me to go through it again? That last step? Okay, good. And I can help you later, okay? All right. A lot easier than how we did it before. You guys agree? With row operations? Now, you might get... So tomorrow, you listening? You might get one problem on your test that looks like this, okay? So what you're really finding out, three-dimensionally, is how planes intersect, right? What if they're parallel, they'll never intersect? That could happen tomorrow, and if you get one really weird answer, you might say, wait a minute, there's no solution. Because the calculator might say something weird to you, and you're like, wait a minute, there can't be, if there's no solution, then they might be parallel, right? If they all intersect in a point like that one does, then you have three planes intersecting in three-dimensional space in one point. And that's what we did. All right, now, let's take a look at number 6, okay? Number 6, I'm going to get to my graph paper again. Okay. So number 6, let me slide this up. So I'm going to have 6 is graph f of x, 1/2 x plus 3 squared minus 2. Now, I like this because this is easy. It's in vertex form. This is an easy one. It's in vertex form. So I know my vertex is at -3, -2. All right, that's a good place to start. It's always the opposite of the inside. And I'm going to put down my graph. My vertex is at -3, -2. It's right there. Now, I know my line of symmetry has to go right through it. So I know this already. Boom, there's my line of symmetry. So my line of symmetry is x equals -3, right? Because it's got to go right through it. We know that. The vertex is in the middle. Line of symmetry goes right through, okay? And now, we also need, so if I graph it in, it's going to look something like this. Increasing, decreasing. Well, this is not hard. Where's it going up and where's it going down? Increasing, decreasing. This is not too bad. Increasing is where it's going uphill. So right at -3, it's at its bottom, right? So from -3 to infinity, it goes uphill. So it's increasing from here, right? So we're going to say from -3 to infinity. It's going uphill. Where is it decreasing? Well, that's easy. Where is it going downhill? From -infinity to -3. Okay, thumbs up. We've done all this. All this is a review. We've done all this stuff before. Okay. All right, now, ready to turn the page? Okay, now number 7's not hard. It's really not. If I draw a picture, it's going to help. A suspension bridge. Okay, so a suspension bridge, oh gosh, it's like the Golden Gate Bridge, or like the bridge in Wenatchee that has that big water tube in it that has the bike path. That's a suspension bridge. So it's got a cable. So a suspension bridge, it's got a cable. Now that looks like a parabola, right? And we get an equation that is also a parabola, right? So it says okay, so at what height will the cable be close to the bridge? Well, that's, again, the vertex, right? That's the vertex. And so if I want to find the vertex, I have an equation, right? I have an equation, x equals negative b over 2a for the vertex. All right, well, a is 0.002, b is negative 0.2, so I'm just going to use my formula, and I'll go a negative 0.2 over a 2 times a 0.002. Okay, and I'm just going to use my calculator. So that's really like 2 over 0.004, 0.2 divided by 0.004, and I get 50. Okay, well that tells me something. So if x is 50, that means right here, 50 feet into the bridge is the lowest spot, but that's not the height, right? But right there, I'm at the lowest. How do I find the height? We plug the 50 in. Right there, we're standing at the lowest spot. To get the lowest spot, we plug that in. So I'm going to take my 50, I'm going to plug it in. So I plug it into my equation, and I'm going to go and write h, if I have, yeah, I got room up here, h of 50, 0.002 times 50 squared minus 0.2 times 50 plus 60. And I'm just going to let my calculator do the work, right? Let's let the calculator do most work. 0.002 times 50 squared minus 0.2 times 50 plus 60, and I get an answer of 55. So that means the height here is 55 feet. So it's 55 feet high. Okay. How am I doing? Now number 8 is what we did yesterday. So we're going to let the calculator do it. And we're going to find the stat button, right? Remember how we did this yesterday? So if you weren't here yesterday, I'm going to go through it slowly, right? So if you weren't here yesterday, we're going to go. We've done this before, but we did the stat button before, but we did it with linear. So if you're absent, we did this again yesterday, but instead of linear, we did the quadratic. So I'm going to go ahead and go to stat, right? I'm going to edit. I'm going to clear my list, clear my old data, and then let's let this be list 1 and list 2, right? So I'm just going to put in the numbers. 3, enter. 4, enter. 5, enter. 6, enters. 7, enter. Okay. And we'll go list 2, 112 or 112,000 bears sold. 125,000 bears sold. 132,000 bears sold. 133,000 bears sold, and 128. So it makes sense that if your price is super low, you'll sell a lot of bears, but you won't make much money. If your price is too high, you won't sell very many bears, right? So somewhere is the perfect price. So what I'm going to do then is, again, I'm going to go back to stat. We did this yesterday. I'm going to calculate, but this time my quadratic regression. So We want the quad reg. So I'm going to go down to quadratic regression. And here's my answer. There's A, B, and C, which go here for A, x squared, 34x plus 37. So my equation would be y equals negative 3x squared plus 34x plus 37, okay? All right? Now, it seems like the best price is about $4 or $5, right? You look at the chart, looks like the best price might be about $4 or $5, but it might be like $4.50, might be $4.25. So the best price would be the vertex again. So the best price, again, is going to be a vertex. So we're going to use our x equals negative b over 2a again, right? So, all right, I've got my a, b, and c, so I'm going to go a negative 34 over 2 times negative 3. 34 divided by 6, hold on, clear. 34 divided by 6, I can answer about 5.66. Or we'd sell them for about $5.67 would be the very best price. Last question. Last question. So, here we go. 9. The totally different problem. So we've got a total reimbursement for driving a car in miles can be modeled by this. Okay, so it's 45 cents a mile. That's 45 cents a mile. Plus a $5 cleaning fee. Does that make sense? 45 cents a mile plus a $5 cleaning fee. But then they realize, hey, we can make more money. Let's change it. We can make more money. And so let's go $8 more, add it on for the cleaning fee. And then we'll do a total reimbursement multiplied by $1.30. So what I'm going to do is this. We're going to add in the 8. So I'm going to go 0.45 m plus 8. And then the total reimbursement, we're just going to multiply the whole thing by 1.3. Okay, so we're going to increase it. We're going to make more money, okay? So what's my new equation? Well, that's easy. G of x is equal to, I don't know, clear this, 0.13 times 0.45. I get an answer of 0.858 m plus 1.3 times 8, 10.4. Okay, that's my new model. That should be easy. That shouldn't be hard for you. Now, somebody rents our car for 190, brings it back at 195 miles. What are we going to charge them? Plug it in, right? So somebody rents our car. They drive it for 195 miles. What are we going to charge them? So we just plug in our 195 into our new equation. So we take 195 and plug it into our new equation. We'll see, all right. We're going to go 0.585 times my 195 plus 10.4. And I'm going to use a calculator, obviously. Got to use a calculator, right? So let's see how much money we're going to charge them. 0.585 times my 195 plus 10.4. They're going to owe me about $124 and about 48 cents. $124.48. Okay, so that's it. That's what your test is like.